Good morning, boys and girls, and welcome to another episode of Pep's Corner. Today, we will begin a brand new book. It is titled Volcano by Patricia Lauber, and it's The Eruption and Healing of Mount St. Helens. We will be reading for our focus and purpose has been posted on the screen. We are in week 10, day 1, chapter 1. We will be reading from pages 1 through 8. Let's begin. Page 1, Chapter 1, The Volcano Wakes. For many years, the volcano slept. It was silent and still, big and beautiful. Then the volcano, which was named Mount St. Helens, began to stir. On March 20th, 1980, it was shaken by a strong earthquake. The quake was a sign of movement inside St. Helens. It was the sign of a waking volcano that might soon erupt again. Mount St. Helens was built by many eruptions over thousands of years. In each eruption, hot rock from inside the earth forced its way to the surface. The rock was so hot that it was molten or melted, and it had gases trapped in it. The name for such rock is magma. Once the molten rock reaches the surface, it is called lava. In some eruptions, the magma was fairly liquid. Its gases escaped gently. Lava flowed out of the volcano, cooled and hardened. In other eruptions, the magma was thick and sticky. Its gases burst out violently, carrying along sprays of molten rock. As it blasted into the sky, the rock cooled and hardened. Some of it rained down as ash, tiny bits of rock. Some rained down as pumice, frothy rock, puffed up by gases. Together, the lava flows show ash and pumice built in a mountain with a bowl-shaped crater at its top. St. Helens grew to a height of 9,677 feet, so high that its peak was often hidden by clouds. Its big neighbors were built in the same way. Mount St. Helens is part of the Cascade Range, a chain of volcanoes that runs from the Northern California into British Columbia. In the middle 1800s, a number of small eruptions took place. Between 1832 and 1857, St. Helens puffed out clouds of steam and ash from time to time. It also gave off small flows of lava. Then the mountain fell still. For well over 100 years, the volcano slept. Each spring, as winter snows melted, its slopes seemed to come alive. Wildflowers bloomed in meadows. Bees gathered pollen and nectar. Birds fed, found mates, and built nests. Bears lumbered out of their dens. Herds of elk and deer fastened on fresh green shoots. Thousands of people came to hike, picnic, camp, fish, paint, bird watch, or just enjoy the scenery. Logging crews felled tall trees and planted seedlings. These people knew that Mount St. Helens was a volcano, but they did not fear it. To them, it was simply a green and pleasant mountain where forests and firs stretched up the slopes and streams ran clear and cold. The mountain did not seem so trustworthy to geologists, scientists who studied the earth. They knew that Mount St. Helens was dangerous. It was a young volcano and one of the most active in the Cascade Range. In 1975, 2 geologists finished a study of the volcano's past eruptions. They predicted that Mount St. Helens would erupt again within 100 years. Perhaps before the year 2000, the geologists were right. With the earthquake of March 20th, 1980, Mount St. Helens woke from a sleep of 123 years. Magma had forced its way into the mountain, tearing apart solid rock, and snapping of that rock set off the shock waves that shook St. Helens. That quake was followed by many others. Most of them were smaller, but they came so fast and so often that it was hard to tell when one quake ended and another quake began. On March 27th, people near Mount St. Helens heard a tremendous explosion. The volcano began to blow out steam and ash that stained its snow-white peak. Small explosions went on into late April, started again on May 7th, and stopped on May 14th. The explosions of late March opened up two new craters at the top of the mountain. One formed inside the old crater, the other formed nearby. The two new craters grew bigger. Soon they joined, forming one large crater that continued to grow during the next few weeks. Meanwhile, the north face of the mountaintop was swelling and cracking. The swelling formed a bulge that grew outward at a rate of 5 to 6 feet a day. Geologists were hard at work on the waking volcano. They took samples of ash and gases, hoping to find clues as to what was happening inside. They placed instruments on the mountain to record earthquakes and tilting of the ground. They kept measuring the bulge. A sudden change in its rate of growth might be a sign that the volcano was about to erupt. But the bulge grew steady, and the ash and gases yielded no clues. By mid-May, the bulge was huge, half a mile wide and more than a mile long. It had swelled to about 300 feet. On Sunday morning, May 18th, the sun inched up behind the Cascades, turning the sky pink. By 8 a.m., the sun was above the mountains. The sky blue, the air cool. There was not one hint of what was about to come. At 8:32, Mount St. Helens erupted. Billowing clouds of smoke, steam, and ash hid the mountain from view and darkened the sky for miles. The eruption went on until evening. By its end, a fan-shaped area of the destruction stretched out north, covering some 230 square miles. Within that area, 57 people and countless plants and animals had died. Geologists now faced two big jobs. One was to keep watch on the mountain to find out if more eruptions were building up. If so, they hoped to learn how to predict the eruptions. The other job was to find out exactly what had happened on May 18th. Most volcanic eruptions start slowly. Why had Mount St. Helens erupted suddenly? What events had caused the big fan-shaped area of destruction? What had become the mountaintop, which was now 1,200 feet lower? The answers to these questions came slowly as geologists studied instrument recordings and photographs, interviewed witnesses, and studied the clues left by the eruption itself. But in time, they pieced together a story that surprised them. This eruption turned out to be very different from the ones that built Mount St. Helens.